Hello, and welcome to day 33 of learning ML from chatgpt. So let's get started. So in today's lesson, we're recapping days 21 to 25. So let's get started on the first one. So here we're doing PCA, which is like separate our data into like different groups. So PCA, is we have an analogy here. Let's see what it says. Simple analogy. Imagine rotating a cloud of points in a 3D space and looking at it from different angles. PCA finds the angle that shows the most spread out view of the points. That's why it looks very spread out and like amalgamated. And here we have TSNE, and we can see what this does. So the analogy for this is imagine taking a piece of paper with lots of data points marked on it, crumpling it up, and then flattening it into a smaller piece without losing any of the relative distances between neighboring points. So that's why, so it's getting, sorry, this is the second one, shorter, and that's why you can see them more clumped together, more like distinct in where the boundaries are. Okay, and now we go on to LDA. So LDA, linear discriminant analysis. So the simple analogy for this was imagine trying to draw a line that separates apples and oranges as far apart as possible in a scatter plot. So it's kind of a bit like SVG, like separating two data sets rather. So here we can see LDA has this sort of pattern. So then going on to day 22, let's see what we did. So we had a random forest classifier. We can just go on to the next lesson here. Day 22. No, we already had this one. That was grid search. Oh no, we are supposed to have random forest, I think. Okay, let's just see. So here we're creating a model, a sequential model. Dense layer, 12 input neurons, input dimension is 8. Rel activation function for the first two hidden layers. Sorry, not an input layer. Then we have dense layer, and output layer sigmoid, which one output neuron, so it gives probability for 0 and probability for 1. Because probability, like the other one will just be 1 minus that other probability. Then binary cross entropy, which is our loss for binary classification. Okay, we have a Keras classifier, and then we're going to do, we're going to use, where's it gone? No, sorry. So we are using a random forest classifier as an extension to the Q tables that we saw before. And we can see that our accuracy is 100%, which is extremely good. Can't get higher than that. Okay, then here at Keras classifier, classify the data, and then we're going to do. Oh, but we got an error in this one. Okay, let's try run this again, see if it will work. As this time installed it after. It may not work though. Okay, I'll just move on to day 23. This is where we loaded and saved models to Flask. So we can use Keras.load model, and we can deploy these using Flask and post request. So we predict it by getting the JSON, and we can use JSONify to like convert it into one that we know. So into day 4 here, let's just see XGBoost. Okay, so what is it saying about here? Model into chatbot, a game theory-based approach to explain individual predictions. To approach individual predictions on models, chatbots quantify the contribution of each feature to the prediction. Okay, so then here we're just using a pre-trained model, XGB. So if I go back here, yeah, we're just having an explainer, shout values, and we're going to plot them. But we've got an error in this. We had the line, which if we go back here, we can see that It's a technique that approximates a black box model by training interpretable models locally around predictions. Okay, and now moving on to day 25. We can see we're using the MNIST dataset here, and we're reshaping our data because we need to have it in a range of 0 to 1. So we're dividing by 255, and we're having it as the type float 32. So we're doing that same thing for the Y train and Y test. Then we're having X values and Y values, X train, Y train. Strategy, we're using a mirrors strategy, so we can go to this. If I look at this, okay, so here we're having the mirrored strategy, and then we're using strategy.scope, and we're having a sequential model, 128 input neurons, input shape 784, which is 28 squared, because it's 28 by 28 image, MNIST dataset, rel activation function, then the output there is 10 output neurons, softmax function, because probability of each of the neurons. Then Adam optimizer, sparse categorical entropy for multi-class classification, and accuracy metric, and we can see that we're getting a good accuracy here of 98%. And then finally here, we're also doing the mirror strategy, but this, I think, the change of the hyperparameters where we got a little bit less with 97% accuracy. So yeah, that's all for today's lesson. So thank you for watching, and I'll see you in the next video. Goodbye. And I think, yeah, that'll be the last recap lesson tomorrow, and then the day after that we'll go on to our project. Okay, which I think we'll do some sort of classification task, because we're allowed to pick for this one. So thank you for watching, see you in the next video, goodbye.